Okay, so we were discussing application of differential equation. Let's continue with that. Yesterday I had given one question. Have you tried that question?
Yes, sir.
Have you done it?
Yes, sir.
Okay. Okay. Let's take another question. Today we will discuss few more important questions from previous year question paper, and yeah, after that we'll be done with this chapter. Then we will move ahead. If you are having any doubt from here, please let me know. We'll be taking those questions over here also. Okay, just a moment. So the question is, just a moment, no? I don't know what is happening over here. Just a moment now. I don't know why nothing is working over here. One note, whiteboard. Everything is getting just creating problem. Okay. Okay, let's take a question over here only. Can you see the screen? Can you see the screen?
Yes, sir.
Okay. So I'm writing it over here only. So the question is, find the intervals in which the function f is given by f of x is equals to tan x minus 4x, where x belongs to the interval 0 to pi by 2, is part A is strictly increasing and part B is strictly decreasing. So the question is, find the interval in which the given function, the function we are having as tan x minus 4x, interval is given. Okay, here we have to take x uh, from 0 to pi by 2. In between this interval only our x value must lie. Is strictly increasing and strictly decreasing. We have to find the intervals. What to do over here?
Differentiate.
Differentiate. So first we'll be finding f dash x. It will be tan x. The derivative of tan x is what?
Sec square x.
Sec square x. And 4x will be only 4, right?
Yes.
Now that is equals to 0 we will do to get the critical point, right?
Yes.
So sec square x is equals to 4. Sec x is equals to plus minus 2. Here the value must lie, the x must lie in between 0 to pi by 2. So obviously we have to check for 2, positive 2. So, so what angle gives us 2 for sec theta? Which angle is 2? Huh? Which angle is 2? Cos pi by 3 is 1 by 2. Is it so? Cos pi by 3 is 1 by 2 or what?
60 degrees 2, I think so.
Yeah. So cos sec is the reverse of cos. So obviously sec pi by 3 we will get from here. Yes or no? 60 degree, yes.
Yes, sir.
So x directly I am writing over here that we got x as a pi by 3. Okay, there will be a different possibility for the angle, but we must think about in between 0 to pi by 2 only. Okay, so our x value is pi by 3. That is 60 degree the way you say. Now we have to check. Let's draw the number line. We must take 0, pi by 2 as the end point, because that condition is given over here, and pi by 3 our critical point, we must locate it over here. When the condition is not given, then what we take minus infinity to plus infinity, we draw the real number line, and then we start checking on the left side of the critical point, on the right side of the critical point, whether the function is increasing or decreasing, right? So here also we just have to do the same thing. So in between 0 to pi by 3, we have to check whether the function is increasing or decreasing. Let's take any angle. Pi by 3 means 60 degree, you already know. So in between 0 to 60 degree, let's take an angle and check f dash x for that angle. Okay. So in between 0 to 60 degree, which angle we can take? Let's take any angle. Which angle you wanna take?
Pi by 6.
Okay.
Pi by 6.
So Yeah, pi by 6. So let's check f dash x for pi by 6. So sec square pi by 6 minus 4 will be sec square pi by 6 will be sec square pi by 6 minus 4. This is f dash x. Okay, we have to check whether f dash x is positive or negative. Will it be positive or negative?
Negative.
It will be negative. Let me check. So pi by 6, what is the value of sec pi by 6? What is the value of sec pi by 6?
The root 3 by 2. Sorry, 2 by root 3.
2 by root 3. Square we will do 4 by 3 minus 4. Yeah, it is negative we are getting. And in the like on the other interval pi by 3 to pi by 2, 60 in between 60 degree to 90 degree. Let's take any angle and check whether it will be positive or negative. We know for 60 degree, the value of sec is 2. Okay, there it's 0. Then for 90 degree, it is for 90 degree, what's the value of sec theta?
1.
1. So there it's negative. In between that, if we will take any angle, which angle we can take? If we will take, let's say 75 degree. So sec theta is what at this angle?
Pi by
We
3
need to
plus
check. Yeah, we need to check it. Okay, by using
pi
the
by 4
formula.
plus pi by 3.
Pi by,
4 plus pi by 3.
yeah, pi by 4 plus pi by 3. Sec, which can be written as 1 by cos pi by 4 plus pi by 3. We know cos A cos B minus sin A sin B. So cos A, it is getting more calculative. Let me check other way of doing it, other way of taking the angle over here. Just a moment. Can we take the conversion transformation rule over here? Okay, let's do it this way only. So we will be having 1 by cos A cos B, cos pi by 4, 1 by root 2, cos B, cos pi by 3. That means cos 60. Now only it was 1 by 2. Minus sin A sin B, sin pi by 4, 1 by root 2, and sin 60 root 3 by 2. So we will be having 1 by 2 root 2 is the LCM, and here we'll be having 1 minus root 3. Root 3 value is 1.7 something. Okay, so here we are getting a negative value. If we will do the square of that, here we are getting, can you see we are getting a negative value? Can you see?
Yes, sir.
Yeah. So we are having 2 root 2 in the numerator, and in the denominator it is 1 minus root 3. Root 3 value we know it's 1.7 something. So that we will substitute over here. So it will be 0.7. We just need to check whether we are getting positive or negative. Accordingly, we will decide that where exactly the function is increasing and where exactly the function is decreasing, the intervals. Okay. So In the numerator, 2 root 2 as it is I am writing. In the denominator, it was negative. Okay. So eventually we have got a negative result. If we will do the squaring of this one, and then if we will subtract 4 from here, we have to check whether it will be positive or negative. So if we will do a square of this one, so in the numerator it will be 4 2 times 8, and in the denominator it will be 0.7 square, 0.49. Okay, that minus 4 we will do. So 8 we are dividing by 0.49. Are we going to get positive result over here? Can you see?
Yes, ma'am.
It will be positive, right? So in the interval, the first interval 0 to pi by 3, our function is negative. F dash x is negative. That means function is decreasing. And on the other interval, pi by 3 to pi by 2, it is positive. That means the function is increasing. So we have to write where exactly the function is increasing, where exactly the function is decreasing. Now, meanwhile, let me check now OneNote is working or not. Okay, still it's not working. Okay, so we got that our function is increasing in the interval pi by 3 to pi by 2 and decreasing in the interval 0 to pi by 3. Is it clear to everyone?
Yes, ma'am. Like in this case, we don't have to do second derivative test.
No, we don't have to do. Here only we will be able to decide that f dash x is lesser than 0 in which interval, f dash x is greater than 0 in which interval, and hence we can say the slope is going down, function is decreasing, the slope is going up, the function is increasing. Okay,
Okay.
let's move ahead. How to take the new page over here like this. Anyone knows how to take the new page over here? Because this software is updated version. Previously there used to be a plus sign at the like right corner, and from there we used to select. Let me join again now. Let's do it here only. Okay. I am unable to select the. You all can see my screen, right? I am unable to select the marker. This is quite okay. Now I can. Yeah, now I can. So the next question is, let's do it quickly. Find the intervals in which the function f of x is equals to minus 3 log 1 plus x plus 4 log 2 plus x minus 4 over 2 plus x is strictly decreasing, strictly increasing. We have to find the interval. Okay, I'm not writing the remaining part of the question. Here also we have to check in which interval the function is increasing, in which interval the function is decreasing. So like that only we'll be doing it. But here you can see the function. We need to do it. We need to find the derivative, the first derivative at first. So that will take time, right? We are having minus 3 log 1 plus x, then 4 log 2 plus x, and then one more function is there. So it will take a few minutes to find the derivative. So the first function, like minus 3 log 1 plus x, it will be minus 3 over 1 plus x, right? Right? Plus 4 log 2 plus x, it will be 4 over 2 plus x. Yes or no? What will be the derivative of this one? Minus 4 over 2 plus x. What will be the derivative of this one? Let's apply a quotient rule. Okay. Or we can also do it directly. We can say it's 4 over x plus 2. We can assume it like a x only. So we will be having 4 over, we can say it's 4x plus 2 to the power minus 1. So nx to the power n minus 1 will be doing. Let me know what we are going to get after doing the derivative of this one. Yes, anyone from here? 4 by x plus 2. What will be the derivative of this function? Yes. Can we write it like n x to the power n minus 1? Can we do it like this? Which will give us, are you getting it? Since we have treated this x plus 2 as only x, so again we need to do the derivative of this one by chain rule, but you know this is x, it will be 1, 2, derivative of that will be 0, so we are not getting any other term besides that. Plus 4 by x plus 2 square. Is it okay? F dash x is this one. Now what we do to check where exactly the function is increasing, where exactly the function is decreasing, to get the interval, we compare it with 0, right? And once we will simplify it, once we are doing the, we have to do the simplification. How we'll be doing the simplification? We will take the LCM, that means 1 plus x, here 2 plus x or x plus 2 whole square. This is the LCM, right? Are you getting it? What exactly are we doing over here, everyone? Or you are getting different differentiation? This is what you are getting after doing the derivative. Yes or no? Let me know. Yes. Are you able to see my screen? Okay. So we will be having minus 3. 1 plus x we are already having. So we'll be having 2 plus x whole square plus 4. 1 plus x. Then 2 plus x will also be there, because 1, 2 plus x is there, plus 4, 1 plus x will be there, is equals to 0. Now we need to simplify the numerator's term. So let's do the simplification. Minus 2a square plus 2ab plus b square plus 4, 2 into 1, 2 plus x plus 2x plus x square plus 4 plus 4x over 1 plus x plus 2 whole square is equals to 0. After that we'll be having here minus 3. Let's do the multiplication, distributive property. Minus 12 minus 12x minus 3x square plus here 2x and x will become 3x. Okay, so here we'll be having 8. Here 4 3 times 12x. Here 4x square plus 4 plus 4x over 1 plus x, 1x plus 2 whole square is equals to 0. Is it clear so far? Are you able to listen to me? Okay, please let me know, because here it's raining and thunderstorm is also there. So I'm still connected. Let me know. Okay. So here we'll be having in the numerator, this is constant, this is constant, this is constant, 8 plus 4, 12, and minus 12, all will just cancel out each other. Now, after that, I can see here minus 12x is there, then plus 12x is there. This, let's cancel them. Then we are having plus 4x over here. Okay. For now, I can see plus 4x only. Okay. Then here minus 3x square plus 4x square I can see. So it will be plus x square. Are you getting any extra term? Please let me know. Okay. In the denominator, we will be having 1 plus x plus 2 whole square is equals to 0. Now we have to find the critical point. So to get the critical point, just a moment, no. Whenever we are having such cases, we take the 0 of the denominator also, we take the 0 of the numerator also, that we locate on the real number line, and then we check in which interval our f dash x is increasing, in which interval our f dash x is decreasing. So if we will take the 0 of the denominator, it will be 1 plus x and x plus 2. That is, if we will, this will give x value as a minus 1, this will give x value as a minus 2, and if we will take 0 of the numerator, so we are having 4x plus x square, that is equals to 0 we will take. That means x, we will take out common, 4 plus x is equals to 0. So x is 0, x is minus 4. So these are 4 points which we are getting over here. Okay, we have to check in which interval our function is increasing and in which interval our function is decreasing. So before comparing it with 0, what we are doing, rather than writing 0 in each and every step, first what we have to do, first we have to do the simplification like this, as you can see. Okay, this is our f dash x. Now we can say this is our f dash x. Now, in which interval f dash x is increasing, in which interval it is decreasing. To check that, we are taking 0 of the denominator, 0 of the numerator. From there, we have got these points. I'll be locating these points on the number line, real number line. So we are having 0, we are having minus 4, we are having minus 2, we are having minus 1 also. Okay, these 4 points we are having. Minus 1 and 0. Okay, let's check in which interval our function, here minus infinity, here plus infinity. So we have to check where exactly f dash x is increasing, where it is decreasing. So if we will take any number in between minus infinity to minus 4, whether f dash x will be greater than 0 or lesser than 0, that we have to check. Okay, so which number can be taken? Let's take any number. Minus 4, let's take minus 5. Okay, let's do it quickly. So 1 minus 5, it will be, the denominator first bracket will be 1 minus 5. That means negative. The other one will be minus 5 plus 2. Again negative, which will give, after doing a square, it will be positive. In the numerator, minus 5 if we will take as a test point, it will be minus 20, plus minus 5 if we will take, it will be 25. So in numerator I am getting positive number, however in denominator I can see it's negative, right? So in this interval we are getting a negative. Are you getting it? Everyone, are you doing it with me? Yes or no? Are you getting the same result? Okay, let's continue. So in the other interval, let's check. In the next interval in between -4 to -2, we can take a number that is -3. If we will take -3, the denominator will be 1 minus 3 negative, -3 plus 2 negative. Again, it will become positive. The numerator's term -2, 4 into -2 -8. And here it will be -2 is square, that is +4. So I can see the numerator is negative, denominator is also negative. Eventually, it is becoming positive. Okay. So in the next interval in between -4 to -2, our function is increasing. Let's check for the next interval -2 to -1. If we will take any number, any negative number, let's say -1.5, if we'll take, we don't have to do the calculation, we just have to check whether it will be positive or negative. Accordingly, we will say whether the function is increasing or decreasing. So 1 minus 1.5, it will be 1 minus 1.5, negative. 2 minus 1.5, positive square will be positive. In numerator, 1.5 into 4, I believe it will be 6 or no. Yes, it will be 6. So here we'll be having 6, and here 1.5 is square, it will be 3. Here it was negative, right? So in numerator, again negative, denominator negative, that means eventually the result is positive. In between -1 to 0, again we have to check. So we can think about any number that is -0.5. And if we will do 1 minus 0.5, it will be positive in the denominator. 2 minus 0.5, it will be positive in the denominator. In numerator, 0.5 into 4 will be 2 minus 2, and 0.5 is square, it will be positive. So it is positive. Now in between 0 to infinity, if we will take any number, let's say 1. So denominator, everything positive. Numerator, everything positive. So it will be positive. Is it clear to everyone how we are checking the intervals? Yes or no? Yes or no? Now we can say the first interval -infinity -4 function is decreasing. The next interval -4 to -2 function is increasing. The next interval -2 to -1 function is increasing. The next interval -1 to 0 function is increasing. And after that 0 to infinity function is increasing. Okay. So for all this interval, the function is increasing. So we can say the function is increasing in interval -4 to -2 union, -2 to -1 union, -1 to -1 to 0 union, 0 to infinity, just like that we can write. Okay. And for decreasing, it is -infinity to -4. Let's move ahead and let's do another question, because this one was similar to the previous concept only, because here we were having question. Due to this type of question, we have done few like calculations was there. These are the extra steps which we have followed over here. Apart from that, everything is same. Okay. Let me take another question. 0 and minus 1. If this is the f dash x in between 0 and minus 1. Okay. If we will take a number minus 0.5, we can take, right? Minus 0.5. And our function f dash x we have got. Please check the calculation properly. Okay. If f dash x is this, then this is the method of doing it. However, the calculation which we have done, if you are doing it with me and you are also getting the same, then we are okay with the calculation. Okay, you need to do the calculation carefully, otherwise the steps will be this only. So if we are having 4x plus x square divided by 1 plus x in one bracket and x plus 2 in another bracket whole square. If you are taking the test point as a minus 0.5, so here 1 minus 0.5, it will be positive, right? It will be positive. This is a square, eventually negative or positive, this will be positive. In the numerator, 4 into 0.5, that means it is okay. Here we are getting negative, I believe, because minus sign I have not considered. 5 4 times 20, it is 2. Okay, here we are getting minus 2, and here we'll be having 0.5 square, that means 0.25. Yeah, 0.25 plus. So this is negative. In the denominator, everything is positive, but in numerator, we are having negative. So yes, in this interval, it will be negative, not positive. That's what I was saying. This is the process we are having. Okay, you need to do the simplification and the testing of by taking each and every test point. You need to check it carefully whether we are going to get the positive or negative. Accordingly, we will say f dash x is increasing or decreasing. Our function slope is going down or function slope is going up. When f dash x is lesser than 0, that means slope is going down. When f dash x is greater than 0, that means slope is going up and the function is increasing. Okay. Yes, thanks for telling me it will be negative over here. Let's move ahead. So the next question is, find the dimensions of the rectangle of perimeter 36 centimeter, which will sweep out a volume as large as possible when revolved about one of its sides. Also, find the maximum volume. Okay, so find the dimension of a rectangle of perimeter. We are having a rectangle whose perimeter is given as a 36 centimeter. Perimeter of the rectangle's formula is 2 times length plus breadth. That is given as 36. If we are saying length is x and breadth is y, length is x and breadth is y. So 2 times x plus y is given already in the question as 36. That means x plus y length plus breadth is equals to 18. That we know according to the given question. Now this rectangle will sweep out a volume as large as possible. So if we will fix this side, if we will fix, let's say we will fix this side. Now just focus on my hand, okay? I'm going to show you. Once we will fix this side, a side we are going to fix, and then we are going to revolve it. Okay, revolve the rectangle like this. Can you see we will be getting a cylinder out of it? Okay, when you will revolve it like this, can you see a cylindrical shape will come out? Yes. So when we will keep on revolving, keep on revolving, keep on revolving, eventually we will be getting a cylinder. Okay. Once we will get a cylinder, now the volume of the cylinder's formula we have to take in consideration over here. Cylinder's volume is, what is the formula for volume of the cylinder? Yes, pi r square h, right? Pi r square h is the volume of the cylinder. Now again I am saying we are revolving it like this. Okay, so eventually this is how we will be getting the cylinder. You can understand this y is becoming the, this y is becoming the diameter, this x is becoming the height of the cylinder. Getting? Are you getting it? So volume we will be having pi r square h. That is the volume formula for the cylinder. That is pi. Radius will be taking y by 2 whole square, and height will be taking x. This is the volume we are having. Okay. What we have to do here, volume as large as possible when revolve about one of its side. Also find the max volume. Now we have to find the maximum volume by doing the, like, by using the concept of derivative, we have to find the maximum volume. Will you be able to do it from here? Please let me know. Will you be able to continue from here? Yes or no? Just a moment, no. Let me check one thing over here. When we will revolve it, uh, just a second. We need to check that this radius will be y or y by 2. Okay, this is something we have to be careful with. Otherwise, this is how we will be getting the cylinder. Just a moment, no. Yeah, now I'm not getting a paper so that I can show you that we will be having a rectangular sheet, and that we will revolve and revolve and revolve. And once we will revolve it, we will be getting a cylinder, and that cylinder's radius will be this y. Okay. So I'll be showing you that picture. Meanwhile, you just try with this one. Okay. We are having pi y square, height is x. This is the volume we are having. We have to maximize the volume by taking the, by using the concept of differentiation. Okay. Next day I'll be showing you it with paper, that how exactly we are getting this as a radius, and height is clear, very clear, that when the cylinder is like this is the height, and when we are just keeping it this way horizontally, this is the height, the same height. Okay, and this height is only x. So height, I believe it's clear. What about radius? We will be I'll be showing you with the help of paper that how exactly we are getting the radius as a y. Okay, meanwhile you just do it and maximize it by using the concept of uh, application of derivative or concept of differentiation. Okay. Is it okay?
Yes, ma'am.
Okay, then
Can you just show the question?
yes. Thank you so much, everyone. I'm keeping it this
Ma'am, can
much
you show the
today.
question?
Yeah. Are you saying anything?
Can you just show the question?
Okay, yeah, sure. This one.
Yes, ma'am.